Hi, in this video we're going to continue look at determining the centroid using integration method. And last time we look at the triangle, figure out the centroid's 1/3 of base and 1/3 of height. And now this time we're going to have a parabola y equal to kx squared and give us the base is a, also the height is b. And remember our first step is always figure out the slope, right? And here intercept is 0 because start at origin. And in order to figure this out, we're gonna see, okay, those two blue points is on this curve, y equal to kx squared, and this point is 0, 0. If you put a 0 as x, you get y equal to 0. You cannot find a k, but the equation is satisfied. Now how about this blue point? It's gonna be a and b because x coordinate is a, y coordinate is b. So if we are going to bring point AB into this equation here, y equal to kx squared, what do we have? Our y is equal to b and kx is gonna be a square. Then we can figure out our k. K is gonna be equal to b over a squared. That's gonna be the slope. Then knowing that, we can actually rewrite this equation. Y is equal to b over a squared x. Some of you might wonder, why do we need to replace k? Because we actually do not know the k. When we are giving a shape, because our goal is to find its centroid, right? And we know a and b and we know this curve. So we need to find the slope. All right, knowing that, we are going to draw our differential element. If I were to draw the differential element arbitrary, and this is going to be my rectangular element, and this is going to be the dx, right here, this length, let me label, that's dx, and this length is going to be our y, because this point on this curve, this red dot is on the curve, so it's going to arbitrarily have x and a y. X and a y satisfy this equation right here. Okay, so knowing that, we are going to look at our differential element. The width is dx, that's differential element length, and this is y, being height. So the area is going to be y times dx. Then if we were to draw the centroid of this rectangle, would be right here, right? Because for the rectangle, it's right that point. So we want to read the x tilde and the y tilde. Basically, that black dot, what is coordinate? And x coordinate is going to be share the same coordinate of this red dot, which is x. The y coordinate is going to be half of the y, right? It's going to be half of the y. So knowing that, we can go ahead, solve our x bar. Our equation said x bar is going to be integral of dA. The top one will be x tilde dA. Then first of all, we need to figure out our x area. So basically that is area underneath the curve, right? Basically it's area of this parabola underneath the curve. So in order to solve that, we're going to figure out integrate of dA. And our a is y dx. So that's going to be, okay, I'm sorry, this is going to be dA. dA is going to be y dx. And x ranges from 0 to a. Now, we are going to replace this y here. Y is going to be equal to b over a squared x dx. 0 to a. Then we can take out the constant b over a squared out. Then we have x dx and 0 to a. then b over a squared, and integrate x, that's going to give us x squared over 2, and x ranges from 0 to a. Then what do we have here? We have 2a squared, b, and x squared is going to be a squared minus 0. So we will cancel out. Let's see. Something is not right. Let's see. Oh, yes, there's a mistake because this equation is not that. This equation is x squared. Okay, so having that taken care of, so this will be x squared, then this is going to be x cubed and 3. Then what do we have? It's 3a squared and b a cubed. The a squared canceled out. We'll have our answer for third, a times b. So that's going to be area of this parabola, okay? All right, now let's look at the numerator. The numerator is x tilde dA. X tilde from step 2 is equal to x. dA is going to be our y dx. Then we're going to plug our y into the equation. It's b over a squared x squared dx. Then take out the constant b over a squared. Then we have x cubed inside integral. Then integrate that x fourth over 4, and x ranges from 0 to a. Then plug it in, we have 4a squared b a to the power of 4th minus 0. Then what do we have? It's going to be 4a squared b. So knowing that, we can find our x bar. X bar will be this x tilde dA, it's a squared b over 4 over our area of this parabola. This is area, basically. It's ab over 3. Then ab canceled out, so the only thing left is a. So we'll have a 3a 4 over 4. That's our x bar, okay? So we find our x bar. So where is that located? So which means this, if I were to draw this x centroid, if the centroid, if we're here, my x coordinate here is going to be 3a over 4. Okay, so if that's this is 3a over 4th, and then I'm going to emphasize this length here to the fatter ends is going to be a over 4. Okay, and remember for rectangle, the centroid, this distance is a over 3, and here is a over 4. Okay, so now let's look at y bar. Our y bar is going to be equal to same thing as the denominator. It's going to be area, which we already know this area. It's going to be AB over 3. Okay? And here I want to shed some light on this. Again, for the triangle, the area we already know is half base times height. If base is A, height is B. And here, if this shape is parabola and that area, you know, it's just, you calculate it, it's AB over 3. Because I want to start to let you to think about the pattern, okay, which I will show you in the next video. But now you pay attention to those answers you have already received. Now let's take a look. Then for this numerator, we will have y tilde dA, right? So now if we were just trying to solve this y tilde dA, our y tilde is y over 2. And our dA is going to be y dx. Okay, so knowing that we can take half out because that's the constant, we will have y squared dx. Y squared, y, we have this expression here. It's going to be b over a squared. That's a coefficient. And then power over 2. It's parabola curve. And that's just y. And then we're going to square dx. Then let's see what we have here. We'll have half 2. But then we'll have a b squared being a constant. And a to the power of 4th. Then inside we'll have x to the 4th dx. When we go ahead to integrate that, we'll have x fifth times 5 divided by 5. The net range x is from 0 to a. So what do we have here? We'll have 10a fourth and b squared and a to the power of 5 minus 0, right? So it will be just a to the 5th. Then cancel that out. We'll have ab squared over 10. Then we're going to be able to substitute that into this equation. Ab squared over 10 divided by ab over 3. Then ab canceled out. Then we'll have just b. We'll have 3/10 of b. Okay. So if I were trying to illustrate that point on this curve here, on this chart, 3/10, it's going to be 3/10 of b, right? That's how we are going to see. So for the base, it's a over 4. But for the height, it's 3/10 of b. And remember, for the triangle, it's going to be, here is also 3/10 of b. As here is 3/10 of a. So that's a difference here. Alright, that's all for this video. We use integration and we went ahead trying to solve a parabola and find its corresponding centroid with a fourth to the fatter end and 3/10 to the fatter end. And then the area, one of the byproducts you learned from solving this, the area is ab over 3. Alright, that's all. See you next time. Bye.